Okay, let's evaluate this. So here let's take x to be sine hyperbolic of u. So using the identity, this would be cosine squared. So this would be cosine squared, and the square root of it would be the absolute value of cosine hyperbolic, and as cosine hyperbolic is always positive, so this would be cosine hyperbolic of u, and the x from here is cosine hyperbolic u du. So cosine hyperbolic u du, and this is 3 sine hyperbolic u minus 1, which is equal to cosine hyperbolic squared u over 3 sine hyperbolic u minus 1 du. But then what? Then it would not be easy. So here's a better way, and let me show it for a bit harder problem, in which instead of this we have also plus x here. So the method is this. Here let's take this plus 1 plus x, or plus x plus 1, to be equal to x plus u. Okay, and now let's square the both sides. X squared plus x plus 1 equals to this squared, which is plus u squared plus 2ux. And from here x would be equal to u squared minus 1 over 1 minus 2u. I just went to this. And from here dx equals to also this squared minus 2u squared, the derivative of this times this, which is 2u times 1 minus 2u minus this times the derivative of this, which is the derivative of this is minus 2 times this, u squared minus 1, which equals to this is 2u minus 4u squared minus 2u squared plus 2. And this minus this is minus 6u squared minus 6u squared plus 2. This is dx, and this was x plus u. So let's plug this into x and write it in terms of u. So it would be u squared. This is x, 1 minus 2u plus u, which equals to 1 minus 2u here, u squared minus 1 plus this times this, which finally would be equal to u minus u squared minus 1. Okay, now let's plug everything. So this is the x, this is x, and this is this, the square root of this. So this would be equal to integral the square root of and so the square root of this, which is equal to this, u minus u squared minus 1 over 1 minus 2u, and this is 3, and x is this. So let me write it, 3u squared minus 3 over 1 minus 2u minus 1, and dx equals to this, times 1 minus 2u squared, this, rather, 2u minus 6u squared plus 2. And of course du here, I missed du. Okay, du. So let's do some simplification. This would be equal to this minus denominator, which is minus 1 plus 2u. So this is minus 4. Okay, and now this goes by this, and what we're going to have, this would be equal to u minus u squared minus 1 times, and this is, let's take a 2 outside, this is u minus 3u squared plus 1 times 3u squared minus 4 plus 2u times 1 minus 2u squared. Of course, du. So the thing is that we turn this integral into an integral of a rational function, which we can evaluate using partial fraction decomposition. Okay, thanks for watching.